how all this stuff goes. So looking at a sine b x minus h plus k. So when you're dealing with a sine function with a shift, what's that, guys? Oh, okay. When you're dealing with sine functions with a shift, what we're going to do here is we're going to list out all of our a, b, our h, and our k's. Remember, what does the h stand for in your shifting? The horizontal shifting. And what does the k go for? Vertical. All right. So here's the way we start these things out. Let's just go with a real simple one. Let's say we have y equals 2 sine of 4x minus pi over 2 plus 2. Let's say we have that. And from this, I want to go ahead and show you guys how I'm going to expect you to be able to reproduce this on your homeworks or on tests and quizzes. So here's what I want you to be able to do. First thing is, we always start by listing our A, our B, H, and our K. Bless you. What's A? B. H. Pi over 2, very good. Remember, change your sign. And K, 2. So that means each one of the coordinates that I plot, I'm going to have to move it to the right, pi over 2, and up 2. We agree? Now, what is your amplitude? 2. Very good. It's always the absolute value of A. Your period. Your period for sine functions, what is it? Very good. Your period for sine and cosine is 2 pi over the absolute value of b. So it's 2 pi over 4, which is pi over 2. Okay? Yes, sir?
I was doing where did you get the 6 at?
The 6?
That's a B.
That's a b. Yeah, it's 2 pi over the absolute value of b.
Yeah, I knew that.
Come on, you've had me for almost 2 years. You can't know. You don't know my chicken scratch yet?
Where do you get the B at again? Is it just a 4, right?
Yeah. It's coming from the generics, the A sine B absolute or parentheses X minus H.
I didn't learn that one.
Yeah, I know. It's a crash course. She'll be fine. You got till Thursday. I know where you eat lunch. So from here, whenever you have a shift function, you always plot your parent function first. Now, I know that I'm going to have to move everything up to and right pi over 2. So what I'm going to do is not draw it right in the middle. I'll draw it over here a little bit and maybe extend it out a little bit further. The only reason that I'm doing that is because I'm allowing for a little bit of extra space to raise my graph up and shift it over to the right side. I'm just using a little bit of foreshadowing to what's going to happen later. All right. Remember, the more space you give yourselves when you're doing a lot of these graphs, better off you're going to wind up being. You'll have a little bit more room. It won't be as condensed. You won't get lost in your fractions when you're splitting out your critical points. So this is a sine function. Sine functions always start at your origin, and it ends at your period. Your period is at pi over 2. All right. Now, when we go to break into your critical values, this is where a lot of you guys are still having problems as far as finding your fractions. Do we all agree that this is pi over 2? If I just say 1/2, are we okay by saying there's still a pi there? All right. Here's what I want you to start thinking. If you're having issues working with pi in the numerator, just treat it as 1/2. So now what you do to break in your critical values. What's halfway between 0 and 1/2? A fourth. What's halfway between 0 and a fourth? Now this is the tricky part where a lot of you guys get scared. I need to figure out what's halfway between a fourth and a half. Now, your calculators will do this for you. Everybody know how to hit the alpha y equals button? If you hit alpha y equals, you get that fraction bar. Yours, I don't think your operating system changed. I'll put in parentheses. Math enter, and you can still do fractions. Now, don't put pi in any of this stuff. Just do 1/4. Oops. And then go plus alpha y equals 1/2. You get 0.75, right? What's half of it? Divided by 2. You get 0.375. Well, mine didn't do it right away. Now I hit math enter, and it spits out 3/8. So knowing how to use the calculator will figure out these fractions for you if you don't remember. Just remember that in the numerators, you just got to keep pi there. Okay. Now I've gotten all my critical values for the sine curve. I know my amplitude is 2. For the sine values, does it start at the 0 or does it start at the a value? It starts at 0. Now the next one, does it go to a or does it go to the opposite of a? A. Since it's positive, it goes to the a value.
Oh, I didn't know what you were talking about.
0, opposite of a, 0. Now here's where I'm going to hold you accountable. This is the newer thing I'm asking you to do. I want you to list these 5 ordered pairs. These are your original points. 0, 0, pi over 8, 2, pi over 4, 0, 3 pi over 8, negative 2, pi over 2, 0. All I did here was just list those 5 points that I just plotted. Does that make sense? Now, for each of these 5 points, I have to shift them now. They're all going to move to the right pi over, they're moving to the right pi over 2, and they shift up 2. Okay? So each of these points goes to the right pi over 2, and it's going to go up 2. So that means I have to add more to my scale up here. I have to add more going this way. So what I'm going to do here is that instead of ending at pi over 2 now, what does it have to end at? Well, add a pi over 2. What's pi over 2 plus pi over 2? Pi. So now it's going to end at pi. It's going to start at pi over 2. Now where the fraction stuff comes into play. You need to add pi over 2 to each of those values. So in my calculator, I'm just going to do 1/8 plus 1/2, math enter enter. It'll give me a new fraction. You get 5/8, right? Everybody know how to do this with the calculator to convert the fractions if you're not sure how to do that? All I'm doing is just adding in my fraction. So now instead of being at pi over 8, it's at 5 pi over 8. Instead of being at pi over 4, it'll be at so that's what, 3 pi over 4. Instead of being at 3 pi over 8, it'll be at 7 pi over 8. Okay? All I did was took each one of these fractions without the pi symbol and used my calculator to create new fractions. So if you're freaking out on how to work with fractions, that's the method to go around it. Okay? Now to all the a values, what do you have to add to them? 2. So now, instead of being at 0, I go right here and I go up 2. Instead of being here, I'm here and I go up 2. Back to here, back to here, and back to here. And what I've done now is created a shifted sine curve. So my new sets of ordered pairs then, basically just adding pi over 2 to the x column and adding 2 to the y column. So it's pi over 2, 2. 5 pi over 8, 4. 3 pi over 4, 2. 7 pi over 8, 0. And lastly with pi, and back at 2. Yes, please. What that's doing is forcing you to be accountable for knowing how to add fractions. Okay? Your calculator does it. There's no reason not to be able to do this. All right? Not so bad? Not asking a lot, is it? All right, let's look at a cosine graph then. Are we good on this? Or do you need another second to continue? Right? Did you jump over any more small children yet? Or are you at like adolescent heights? I think you should be able to jump over Mike. That'd be pretty awesome. And if you miss him, you just get hit in the head and you have to get a haircut, so it'll be all right. So let's look at the cosine graph. Oh, let's see. Let's say we have y equals -3 cosine of 1/4 x plus pi minus 2. What do you think your first step is going to be after you write down the problem?
Yes.
Label all your stuff. Very good. So A, -3. B, 1/4. H is -pi. K is -2. You guys are going to get real sick of H's and K's coming up here when we get into comics. Curves. All right? Not so bad? Amplitude. Remember, your amplitude is your absolute value of A. What's your amplitude? 3. Your period is going to be 2 pi divided by 1/4. What's your period? Very good. Now, I know that in my shifted graph, I'm eventually going to have to move everything over pi to the left, and then I'm going to have to go down 2. So what I'm going to do here, when I draw up my graph, I might extend this down a little bit and bring this just a little bit further over. All right? Remember, you can always go back and doctor it later. All I'm doing is trying to look ahead. So cosine, once again, you always start with 0. And you end at your period. Well, our period is at 8 pi. This one should be very, very easy to break into its quadrants. What's half of 8 pi? 4 pi. What's halfway between 0 and 4 pi? And here is going to be 6 pi. Amplitude is 3. And right now I have everything listed that I needed to start with. So cosines. Does cosine start at 0? Does it start at your A value?
A value.
It starts at my A value. What's my A value?
-3.
-3. Good. So now I just start at my A value. I go to 0. Opposite of A value. 0. A value. my points. Okay, start listening up. -3, 0, 2 pi. Oh, that means, sorry, 0, -3. Hello. 2 pi, 0, 4 pi, 3. Those are all my original points. To each of these points, I'm going to move them to the left 1 pi and move them down 2. So instead of being at 0, I'm going to be at -pi. Instead of being at 2 pi, I'm going to be at pi. Instead of being at 4 pi, I'll be at 3 pi, 7 pi, oh, hello, 5 pi, and 7 pi. Everybody okay with that? I just moved my scale over 1. Now for all the y values that go down 2. Okay. So I just move this point left and down. Left and down. So we're down 2. Left. Down. Left and down. And left and down. And once again, just relist them. And was -5, -2, 1, -2, -5. And by relisting out those ordered pairs, it just holds you accountable instead of just looking at your calculator and going, whee! Okay. Hopefully that's not asking too much. All right. Now, if those of you guys were here on last Friday, then what changed when we graphed tangent? The starting point? Yeah. And what else? What else did the tangent graph have that none of these have? Asymptotes, yeah. Have asymptotes. So let's look at a generic tangent function. I'm not going to do any tangent stuff today that have any shifts. I think I did 1 or 2 last week, but we didn't really get too far into it. So I'm just going to kind of revisit tangent non-shifting. Then we'll go into the shifting of all of it tomorrow with tangents. So let's look at a tangent function. Y equals a tangent b of x. Now, the a value here in a tangent function has something a little bit different going for it. The b value, you still use that to find the period, but what happens with tangent, the period is different. You still list your a value, you still list your b value. The period for tangent functions is always going to be pi divided by the absolute value of b. That's always going to give you your period.
So for tangent changes?
Yeah. And the reason why it changes, when you're looking at the unit circle, tangent changes because here and here, it's 0, 1, 0, -1. Tangent is y over x. Sine divided by cosine. I get undefined there. That's where you get your asymptotes. So that's why the period changes. It doesn't cycle through completely. So you get those asymptotes. So that's why it's at pi. What happened here is your asymptotes are always going to occur on intervals of that. So your asymptotes are always going to be at pi over 2 times the absolute value of b. So basically, you cut your period in half, and that's where your asymptotes are going to occur. It's a very simple formula to follow. Let's read it. No, the period is still absolute value. Because you, excuse me, you can't have a negative time. Does that make sense? I might have forgotten to put the absolute value symbols up because it was the Friday prior to spring break, and I might have already left. Which you might have left too.
I think
We know Jake was already gone, so what's the problem?
See, Mr. Murphy, I think we all left.
Yeah. So let's look at an example of how this works out, and go from there. So let's say we have y equals 2 tangent of 4x. A real simple way to start. So when you have y equals 2 tangent 4 of x, you still do the same thing. You still list out your a value, you list out your b value. Let's start this up. Your a is 2, your b is 4. Your period in this case is going to be pi over 4. Now, that means what's occurring, your tangent graph always starts, the parent function always starts by the origin. The period is the amount of time it takes it to cycle through one graph. The graph of tangent functions either look like this, if a is positive, or it looks like this, if a is negative. All right? So now what happens is, in time for it to make that cycle change through, that's what occurs within the period. If the period is pi over 4, that means my asymptotes are going to be at pi over 2 times 4. Well, what's 2 times 4? 8. So I put an asymptote here at pi over 8, and over here at negative pi over 8. Because 1/8 to 0 is 1/8. 0 to 1/8 is 1/8. 1/8 plus 1/8 is 1/4. This distance here is still pi over 4. What you're doing is you cut it in half to figure out where they are on both sides. Okay. And that's where your asymptotes wind up. Now to find the other shift points that you're going to do is, well, what's halfway between 0 and an 8? 16. So here's pi over 16. And here is negative pi over 16. Your a values what happens for the a values, if a is positive, that means it's starting at the bottom, working its way up to the top right. The a value occurs at this halfway point here between the negative asymptote and 0, and the positive a value between 0 and the positive asymptote. And all you do is this. Since there's no shifting, I'm just going to draw a solid line, connect the dots with a little bit of curve, and you're done. Okay. And just like we did with sines and cosines a couple of minutes ago, I want to label those coordinates. Well, negative pi over 16, comma, negative 2, 0, 0, pi over 16, positive 2. And my asymptotes are at, when you have a vertical asymptote, any vertical line always starts with what? X or Y equals? X equals, very good. It's always going to be X equals, well in this case it's plus or minus pi over 8. Those are my vertical asymptotes. I'm going to ask that you guys write that down.
Yeah, what did you read on?
I know what you're saying, but I want you, because on the test, when I write out the test, I'm actually going to leave a spot for you to label where are the asymptotes. So I want you to just get in the habit of doing that. You still are going to label on your graph, yes, but this is just making sure that you're putting it down on paper, okay? Oh, I know what you mean. Yeah, I guess I see what you're saying. Yeah, I see what you're saying. No, I see what you're saying. That's really all right. Okay. Does this make sense in how we set that up? Okay. Remember, when you're dealing with tangents, it's not going to be, the trickiest part is going to be when you have to worry about the fractional amounts. Once again, all you're doing is finding halfway points. Okay. Since you're starting at 0, you're just finding halfway points. Let me give you one more tangent. I'll let you guys try it. Go and try that one out real quick. Yes, sir. Before we get into the shifting, so your A value is -3, your B value is 1/2. So that means your period is going to be pi over 1/2. So your period is at 2 pi. So your asymptotes are going to occur at pi and negative pi. Do you agree? All right. So we go here. Pi. There's negative pi. There's my origin. Halfway is negative pi over 2. Halfway is pi over 2. My A value is 3 and -3. No scientific nothing. We're putting those on the graph. There's no shifting involved here. It's fine if you go ahead and do that. Since it's negative, it means it's going the other direction. So it occurs here, and it goes to here. Connect the dots. La 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 la. -1/2, or negative pi over 2, 3, 0, 0, and pi over 2, -3. Asymptotes at x equal plus or minus pi. Good? All right. Pause this more time, then I will explain the homework. So on the 14.1 side, that's all you guys got to do tonight. Remember, hands up real fast, please. When you're doing these problems, make sure you list out your originals, and then just for those are the 2 tangents on the 14.1. Just list out your originals and your asymptotes, just like the 2 examples we just did. And then when you do the 14.2, those are all sines, cosines with shifts. So that means you want to list out your original stuff and then your shifted ordered pairs. Okay? Just like exactly the same way I just did in class. Yeah, do this on a separate sheet of paper. There is no way will you be able to fit it